All right, class, so this is the explanation video for the backside, the problem number 3 from the exam handout, or exam review handout. In this problem, I think this is a great stoichiometry problem. It's a little bit more challenging than a typical problem, but I do think that all aspects of this are good and are a good review for our exam tomorrow. In this problem, we're asked to determine the mass of octane that would remain. So that's sort of telling us right away that O2 is going to be the limiting reactant. So if I'm just reading these words, determine the mass of octane that would remain if this mass of octane was reacted with 45 grams of O2. So that is really sort of suggesting that O2 is limiting, right? Because that's sort of saying that octane will be the excess reagent. So that means O2 must be the limiting reagent. When I solve this problem, I'm actually going to show that O2 is the limiting reactant. So I think that'll be a good practice as well. To get started with this, obviously we're going to need to balance this equation first. I'm not going to spend time on this video talking about how I get to these coefficients. I think that at this point in time, you should be able to do that. You should be able to figure out that the coefficients are 2, 25, 16, and 18. If you are still struggling with that, that is something we need to clean up sooner rather than later. When we go about figuring out the rest of this problem, the first thing that I'm going to show is actually determining the limiting reactant or showing the limiting reactant. So the way that I would do that is I would start with my 26.3 grams of octane, and I'm going to rewrite octane as C8H18 just for simplicity's sake. The reason that it's shown like this form is just to help us visualize the molecule. Maybe at this point we're not exactly visualizing molecules, but eventually we'll get there. But for now, I think just writing C8H18 will be a little bit simpler. The molar mass of octane is 114.26 grams per mole, so this is just a grams to mole conversion, and we're going to end up with 0.230 moles of our octane. I'll do the same thing for oxygen. We're starting with 45 grams of O2 times 1 mole over 32.00 grams is going to equal 1.41 moles of O2. Now, the next step to confirm or to show that O2 is actually the limiting reactant, even though I've got way more oxygen, if we look at our ratios here, every 2 moles of octane requires 25 moles, a lot of oxygen to utilize for that reaction. So if I wanted to figure out the number of reactions like we've been doing in class, we could say that one reaction requires 2 moles of C8H18, and we can find that we can actually do 0.115 in quotes reactions, right? So the units there would be the number of reactions that we could do. We'll do the same thing for oxygen, and here you'll see sort of how that 25 comes into play, 25 moles of O2. So with this number of moles of O2, we can actually end up only doing 0.0562 reactions. So each reaction is sort of using up a lot of this oxygen, right? So even though we've got more to start with, we're using it up much, much faster, so it's going to go away quicker. So oxygen is in fact the limiting reactant. This is what this tells us right away, so that's good. So then the question, I would say, becomes how much C8H18 is actually used up? Excuse me. How much C8H18 is actually used? So we're going to base this off of our limiting reactant, right? If we have 1.41 moles of O2 that we know is going to be consumed, then I can use that and do a multimole ratio with octane to figure out this number of moles of oxygen is going to require how many moles of octane. So it's going to be a 2 over 25 ratio. Essentially what I'm doing here is a unit conversion from moles of oxygen to moles of octane. And I will find that it's 0.1125 moles of C8H18. Now, this is really, and I'll put a sort of note here. So this is the moles used in the reaction. So based off of this moles used in the reaction, we could actually figure out what mass of C8H18 was used, and then the difference really between my starting mass and my amount that's used is going to be the amount that would remain. So what we're looking for is that mass that would remain. So the mass that would remain would be, so let me write that down here. So the mass that remains, the excess, should equal the starting mass minus the mass that is used. And we know what the starting mass is, right? The starting mass is 26.3 grams. And the mass that is used, well, we can actually figure that out now, right? We have the number of moles that will be used. So we can convert this moles, 1125 moles of C8H18 times 114.26 grams over 1 mole, so you guys can see, equals 12.85 grams, and that is the mass that is consumed or used up. So this mass right here, right, that comes from this number of moles, which is the number of moles that would be required to react all of this 1.41 moles of oxygen. So this is our limiting reactant. It tells us how much we can use essentially. And this 0.1125 moles, that's going to be the number of moles used in the reaction. So I just converted that into grams. So then to find my final answer, the mass that remains, that's just going to equal the starting mass, 26.3 grams, minus this mass that I've used up, 12.85 grams, and that should equal 13.4 with rounding grams of C8H18 left over. And that is my final answer. Now, in a problem like this, there's lots of different methods. Like there's lots of different ways that we can do this. When we got to this point here, when we're talking about the moles of C8H18, you could use the moles and figure out how many moles you started with, right? Which we know here, and oh, you can't see that. Which we know here, and take that number of moles and subtract this number of moles, right? That's going to lead us to the same answer. So there's lots of different methods. If you did a slightly different method, that's okay, as long as you understand your method. But this is the number of grams that should be left over after we've done the reaction. As you're doing this problem, definitely make sure, this is obviously a lot of work here, a lot of stuff. Make sure that every single step, you really understand why we're doing every single step, and that you can explain it to someone else. It's not going to be good enough, essentially, just to watch this video or go through this once and sort of see the pattern. We really want to know why we're doing everything behind the pattern, and I would really encourage you to focus on that. One other thing, a little tidbit here, in class I suggested finding the mass of CO2 that would be formed. And the answer to that is 39.7 grams of CO2 that would be formed. And that's going to be based off of the limiting reactant. So to do that, I would start with this moles of O2. And I would do a mole-to-mole conversion from O2 to CO2, so using this 25:16 ratio. That would give me the moles of CO2, and then I would convert that just into grams of CO2. So see if you can do that as well. I think that'd be a good exercise. All right.